rehab, primarily the media, but also sometimes structural failures. I think it's been 50-50 through the years what we've replaced. Some is media driven, some is structurally driven. Leaks are developing along the weld lines, other coating failures. The other thing I'd like to point out is any of the filter modifications you're doing, even media replacements, need to go through the Department of Health. Just to get that out there, you need to take it through the Department of Health and get that approved before you proceed with anything. So we'll talk about filter rehab, when to do it, what are some of the causes and different methods to do that. The most basic is just strict media replacement. Above and beyond that is we have structural failures. We're actually trying to do some structural improvements to the filter. And last kind of ties to both is if you have poor filter performance, just trying to improve the overall performance. Media failures, there's a number of different things we think contribute to the failure of media. Part of it's just the scaling of different minerals. You can get biological fouling. I think the 212 corridor has quite a bit of that. Not necessarily the beneficial kind of biological activity, but some of the detrimental biological activity. Under drains, there's some disruption can happen on that. Once the under drain gravel is disrupted, it's hard to recover that. And another one that we have seen a few times is some wells will pump sand, and that will get caught in the media, and eventually that can cause some issues with the filter. Maybe tied into all of these is the air wash system. If you have an air wash system, when those nozzles start to plug, which they seem to do over the course of time, that can start to impact your filter performance. First one that we're talking about is the mineral scaling on the media. Two things that we see most commonly is if you have excessively hard water, and that's in the southwest region of the state, maybe more prevalent than others, where you start seeing hardness levels of 700 to 1,200 milligrams per liter. We do see we can get some hardness scale that seems to interfere with media performance with time. Excessive manganese also seems to create some dirty media, whether that's a true scale or just dirt that doesn't come out. It's another case where we've seen some of the media that gets bad is where you have also very high manganese levels. Some of the effects that you'll see is you have reduced removal efficiency. As the media gets rounded with scale, it doesn't have the sharp edges, there's less voids to catch the iron and manganese particles. So there's less capture area, so they can either have more head loss sometimes. Other times it's just the smaller manganese particles will trickle through faster because there's less places to get caught, and you'll end up with shorter filter runs. One thing to point out is, in our experience, it's not always going to cause higher head loss. May get just shorter runs and more breakthrough. It may not actually have more head loss, even though the media, in theory, is getting dirtier. It doesn't always create that. One of the ways to potentially clean the calcium carbonate type scale off its hardness is acid cleaning. Citric acid, which is NSF approved and you can use in the filters, works very well on that. It'll just bubble up like Alka-Seltzer when you start dissolving that. If you have green sand though is not approved for low pH cleaners, particularly even the name brand ones, they will not approve it. That it's not going to damage that. It's a bit of a gray area. Some people have done it, they think with no ill effects, but if you talk to the green sand manufacturers, they are not going to approve using a low pH cleaner. So depending on the age of it, it may or may not be worth the risk to take. It is a risk. Biological fouling. Again, there's been a lot of talk about biological systems, and there's many that work well, but there are some that aren't designed for it, and you will get some slime-forming bacteria, the Mr. Yuck type that they talk about. It will create the mud balls in the media, which once that starts, you reduce your filter efficiency, may increase the head loss, but in general, you're just creating a bad environment. Usually, again, you can see short filter runs, may see higher head loss, may not always. One of the ways we have successfully handled some of the bacteria issues with shock chlorination. Elimination is probably the wrong word there. It will control the biological growth to the point where it doesn't cause the plugging of the media, gets rid of the slime. Eliminating biological growth is near impossible on many filters because it's either native to the groundwater or it's just such a rich environment for it to live that you can't necessarily prevent it. So there's places where you actually encourage it, enhance it, but some filters, particularly the 212 corridor and others, struggle with some of the biological problems that they've had. Filters that have nearly been plugged with some biological growth. The other sign we often see is just very variable results. The iron may be bounce up and down low. It's not a nice steady breakthrough curve. You may see the iron bouncing up and down, zeros up to 0.2s to 0.3s, back down, which is more unusual for gravity. Under-drain disruption is a little more unusual, but we did have one. There was a pump backwash system. Check valve was getting sticky, was not holding as tight as it should, and the air relief valve wasn't probably quite big enough to handle all that flow when the pipe backflowed and filled with air. Every time it kicked on, it blew some air into the under drain and started to dislodge, we think, the under drain gravel. Once that happens, the media started to work its way down, and they actually found out they had a problem because they were getting media into their clear wall. Media was migrating through the under drain and getting into the clear wall. At that point, there's nothing you can do but go back in, take out the under drain, replace the under drain gravel, replace it, and all the media with it. The other thing I think that would happen is this typically is only going to affect one cell if you have a pump backwash. If you do them in the same order, it's going to be probably the first cell, potentially the last cell, wherever it is. You may have one cell that will be worse than the others, and only one cell will show the effects of that. And that was consistent with the facility we were on. It only had the first cell had the problems, was losing media. You can measure that. There's a difference in media just in the first cell, and we're able to identify what happened.
That was cool. Wow. Wrong button. Where is my...
All right. Better. All right. Typical filter cross section, and this could be for either a pressure or a gravity filter. This particular one is just a gravity filter. We're going to talk about a plenum quite a bit, which is just the open area underneath the under drain plate. With that, you have, typically they have a steel under drain plate with some of the under drain nozzles. Most will have an under drain gravel, about 12 inches. There are a few filters that will have media retaining nozzles, which have the media directly around the nozzles. Probably more typical is that you do have an under drain gravel. A few of the filters have the air wash nozzles. Usually the air wash are right on top of the gravel. If you have that, not all filters do. And then medias are going to vary, but a common scenario would be either about 12 to 18 inches of silica sand with anthracite on top, or 12 to 18 inches of green sand with anthracite on top. So what happens when you get air in the bottom, air comes up through the under drain nozzle and blows the gravel up, which allows the finer media to filter into it, and the media will just keep filtering through. Well sand issues. We've had, all wells can pump some sand. The industry standard allows some sand to pump because you cannot make wells 100% sand proof. A lot of them don't pump any notable sand, but there are those that do. We've had a few facilities that have had sand get captured on their filter media to the point they have to actually get in there and clean it off. The city of Franklin is one that was pretty notorious for that. They would have to get in there and actually clean the sand out of there. Sand can actually get through, it's fine enough, it can get through your media and through your under drain. We've had others that have found well sand in their clear well. So it's a very fine sand can filter through there. That can cause some plugging the under drain nozzles, can cause some other issues. Potentially is going to shorten your filter run times, and it's difficult to backwash out because you're dealing with such a volume in there. The air wash nozzles, this might be a combination of a number of things. When you have the air wash nozzles, they tend to plug with fine media, the well sand scaling, combination of all of those. As they start to plug, you're going to hear the pressure relief valve and the blower going off, which I think all facilities after 4 or 5 years, you start to hear that thing screeching when the blower kicks on. As the outside nozzles are likely to plug first, start to plug, you start to push all the water through the center of the air through the center of the filter. You disrupt the media. When you hit the water, you follow its path of least resistance. It's going to probably want to wash just the center of the filter. Corners and the edges start to get dirtier. As time goes on, that can grow, and you end up with an effective area of the filter just being the center where you're filtering, and potentially can shorten your run times. You should see a similar turbulence across all the filter. If you have pressure filters, it's near impossible to look at it. Even some of the gravity filters, you open the hatch and you've got you have the backwash trough there, and you can see maybe 12 inches of surface area on the entire filter. So it's a hard one to visually inspect sometimes, despite the fact that you should be able to do that. If you really have a concern, a very good way to check that is to backwash it, and then when it's full of clean water after the backwash, turn the blower on. The bubbles pop through and are very easy to see when the water's clear. When you have water of that nature, it's very hard to tell where the bubbles are coming up because it's all just chocolate milk. So if you really want to see it, turn your air blowers on a clean media right after backwash, and you'll be able to see very, very clearly where the air comes up. We talked mostly about that. Anytime if you have an air wash system, you're doing any media replacement, replace all the air wash nozzles. Most of the Tonka, and I believe US Filter do that as a standard. I don't think, if you order media and a filter they know has air wash nozzles, they're going to include that in the price because they know that by the time you take the media out and put it back in place, you're going to either damage them or just given their age, they need to be replaced. So, media replacement, just kind of in summary with that. One of the things that we look at on that is often, do we want to change the media style? That's a common question. The answer to that is maybe, but we would want to run a pilot, and I would recommend everybody would do that. Tonka runs them. We have the trailer. There's multiple ways to do that. People ask, will media improve my filter performance? Maybe. We're still going to want to run a pilot. We're going to want to look at, compare the different medias, balance out the chemical feed to see, will it come out? We've had a few filters that just physically, there's not enough detention time. If you have manganese, then we're going to have very efficient performance. We've had a couple that had silica sand. You could not physically run that in a way that would really take the manganese out well. We ran a pilot. The green sand worked phenomenal. With silica sand was very, very marginal. So, councils often ask me, how long do we before we should replace the media? There's not a defined answer. I would recommend typically every 20 years that you would plan to probably take that down and just inspect the filter. It's a steel filter, it's got coatings, much like a water tower. After 20 years, you should be inspecting it because if the coatings go bad and you start getting corrosion, you could get to the point where you've done some physical damage that's hard to recover. So at a minimum, I say every 20. A couple filters we have replaced media about every 7 years because it's harder water and the performance just starts to go down. So it's a little bit variable in that regard. Looking then at some of the structural failures, leaks that we run into. Aerator plugging. If you have the spray nozzle aerators, those will often plug. Leaks in the plenum, again, under the plate below. That oxidized or aerated air is oxidized. If you've talked to Department of Health, they have some concerns about some of the copper and lead issues on aerated water because it's more aggressive and they tend to have more hits for copper and lead. You've got the same issue in the bottom of the filter. It's a little bit more aggressive, and once it starts to react with the metal, it's a little more aggressive. We see that in two common places. One is the weld joints, and second is the floor. The floor it sits, it's always in contact with trapping the water that gets in it from condensation, and with time that can just eat the floor of the filter away. And last is coating failures. I see Roger from Clara City is here. We're working on one right now in Clara City that has just some small coating failures, but to the point where it was leaking through the filter. We have some photos of that. Looking at the aerator, this one's City of Franklin, and they were pumping a lot of sand. So there's probably a combination of sand and iron scale in the aerator header right there. So you can see how bad that scaled. Then the actual spray nozzles, likely are probably suffering the same issue on that. So you can see that's pretty severe. Best way to treat that is take those off once a year, once every 2 years, and acid treat those. By soaking them in acid, you can usually recover them. If they're scaled to the point you can't, it's a fairly cheap replacement to unscrew those. To unscrew the nozzles right there, they're a threaded fitting usually. You can unscrew those and replace those relatively cheaply. Again, the nozzle plugging, combination of hardness, a little bit of iron scale, you can reduce the flow. And actually, we've had cases where that's actually caused enough head loss, it's actually reduced the pumping capacity of the wells. It's put some back pressure on them and cause some issues there. Again, you can clean with acid and you can replace pretty cost effectively. This picture is Clara City. They had three pressure vessels. Two of the three sprung leaks, very similar to that, both in similar location. We went inside, took a look at that. It appears the coatings were nicked when they're putting the media in, and they had 20 to 25 little spots along the bottom of where the media is. Coatings were nicked, started to get corroded into the metal. A couple spots had gotten through, and a few other spots was getting dangerously close to popping through. So it was relatively easy to weld and fix, but you have to take the media out, recoat it. So it's not necessarily a cheap proposition. It is difficult to coat the plenum on a gravity filter. If you recall, and even on your filter, it's the bottom 12 inches. It's a box. You weld the top on or bolt the top in. The only access you have is through the 6 or 8 inch effluent pipe. So it's very difficult to inspect. It's very difficult to coat. So it's really the weak spot on some of those filters. One of my more embarrassing moments was at a facility. They were rusting through. They had patched a couple spots. The paint was bulging. You could see there was a little bit of rust underneath it. As we were walking around counting the number of spots we had to patch, kind of pointing them out, I accidentally touched one of those and it actually popped the hole. The paint was that thin that just by sheer touching it, it relieved the pressure and it blew a hole. We at that point walked around, took a pocket knife, and they just pierced the paint, and then about 3 more spots, it actually blew little holes about the size of your little finger right through that. So that was an emergency filter rehab, similar to what Brian is going to show you how we redo the under drain on those. Absolutely. Mike just asked about dehumidifiers. We strongly recommend dehumidifiers. They make a phenomenal difference in water plants. The most common we see is the high E dry. They've got the 2 different sizes. There's others out there, but that's one I see very common everywhere. It's well worth its money. And for most people, I'd recommend you get 2 of them. You just have redundancy that if one happens to fail, you have the other one that's working. One probably can cover the plant, but they're not that expensive, and I'd recommend, if I'm talking to council, get 2. Absolutely. So they are actually cheaper to operate than the old style Deskin style dehumidifiers. A few of you may have seen those, the great big skids that are bigger than the table here. There's much more energy efficient even than the old ones were. Coating failures, again, reference Clara City. This is the inside, just showing one of the pits. You can see the welding rod there. It's a very small pit. They actually ground that out, so it's rounded now, but that's how small and pinpoint it was, but it was working its way through, which is a big failure, a little failure, it's a failure. They don't differentiate. Again, we think in this case it was scratching. We see it often also on welds. We think where the welds get a little bit of heat damage there, or they don't grind them off well enough. We see some problems there. The best fix is to get inside and fix it. As it was in Clara City, we probably could have put patches all around the outside. They were so small it probably would have lasted for another 15 plus years. At that point though, we had no idea how widespread or how big that was, if it was just a very small pit or if it was a major corrosion growing across the whole thing. So really had no choice but to go inside and take a look and confirm what was going on. Again, an exterior patch will work, but if you don't know what's going on, it's not going to stop the problem. Poor filter performance. The signs of what's going on, you're going to have either increased head loss or shorter runs. That's when we're looking at changing media. Just kind of summary is, if you have shorter runs, treatment results, obviously that's, the proof is in the pudding. If you're getting good results, don't fix what's not broke. If you're getting media, if you're blowing media with your backwash, might be another one to look at. You may always get a little bit, but when you're getting it to the point where you can actually see changes in your filter levels, again, I'd recommend you all measure the level of the media in your filters. If they're gravity filters, a little bit hard root pressure, but measure from the hatch to see, 1, that all the cells are equal depth, and 2, that you have a record of what it is. Some facilities think they gain media because as they pump well sand, they actually accumulate some sand in there, and they surprise themselves and go in there and measure it. They actually have what they think is more than they had previous. Others can lose a significant amount. User complaints, some of the small facilities, you may have a breakthrough that you're not catching. Your users will notice it. They'll call you and say you've got red water, even if the times you sample you're not seeing it. But that said, our recommendation is when you're dealing with issues is to sample, and when in doubt, sample again. Iron test data, manganese test data, both at the filter, out in the distribution system. We'd recommend, it's hard to have too much data on that. Part of the value of even testing the distribution system is if you're testing at the filter, you're taking a snapshot of that moment when it comes out of the filter. If you have a breakthrough 1 hour before backwash that you don't catch, you may never sample that, but if it blends in your tower, if you take a sample of the system, you're gonna get a blended composite, and you may see your numbers higher in the system than they are when you're sampling the filter, and that's gonna tell you that there's potentially something going on that you're missing. Brian will probably harp on sampling more than I do, but we really think that's one of the valuable things. The Hawk DR 800s, 2000s, they're a pretty cheap piece of equipment. It takes 3 minutes to run the iron test. Again, we think they're worth their weight in gold. With that, I'm going to turn it over to Brian Goulden, who's worked on a couple filter rehabs, and I'll let him carry the second half here.
Okay, everybody hear me all right? So John kind of took you through some of the things to look for, reasons we might want to do a filter rehab. I wanted to focus more on the actual rehabilitation itself, walk you through a kind of case study, and then talk about some of the lessons we've learned through different projects. So the rehab process, really, you got to start off with a demo, and that's going to be removing your media and then removing any steel or piping in the system which you need to replace. That's going to vary case by case depending on your own system. Next, we're going to be looking at sandblasting and recoating the interior of your tank, again on a case-by-case basis. If we're doing a full rehab, we'd be looking at plenum repair and installing a new under drain, and then of course new support gravel and media. So first, the demo. We need to remove the existing media. Typically that's going to be with a vac truck. Might be a day or 2 day process to get that completed. And the second part of the demo would be removing any steel piping or supports or under drain that we need to remove that's been damaged. Next there'd be the new coatings done, and this is again referencing Clara City. This is a picture of their pressure filter on the inside before and after the recoating of the inside of the pressure filter. So looking at the plenum repair, this goes back to that slide John showed earlier about the actual structure of your filter. So when we rehabilitate that filter, we're going to do a couple things in there. Of course, first we're going to remove the media on top of the under drain, but then we're actually going to cut out the steel under drain plate. From most of your existing filters are going to be set up in this manner. We're actually going to go in and adjust how that under drain system works. And then following that, we're going to install new under drain piping in the plenum and rebuild that filter back up from the inside. So here's a snapshot. This is a rectangular gravity filter. We're rebuilding that plenum. As you can see, there's kind of a small steel ledge, and that's where the original plate would have been bolted to. We've removed that. Now we're going to rebuild the under drain system up from the bottom. Those red dots is actually where water collects in the under drain nozzles. That water is then going to be, the filter water is going to be removed out to the exterior of your filter, and that's where your exterior piping manifold is going to be connected to your filter. Of course, during the backwash process, water is going to come in the opposite direction up through those nozzles to backwash your filter. So during the plenum repair, if you're on site watching the contractor work, here they've actually prepared that filter cell for pouring the concrete block for the under drain. So that concrete is going to be poured in and basically coat that entire piping system except for those red nozzles, which is actually a cover on there for a threaded piece so they can thread in the nozzles after they pour the concrete. Once the concrete is poured, this is what that's going to look like. Again, there's concrete poured around the under drain piping, and there you see the black nozzles. In this case, these are not media retaining nozzles because we're going to have support gravel But this is where the water actually enters the under drain system and move on to your clear well or high service pumps. That center pipe you see is actually the air wash header. And with that air wash header, there's supports for laterals. And that's actually where your air wash is going to come in for the backwashing process. If we move on from there, we've now had gravel placement. And here's where you see those air wash laterals. So your air wash laterals are right at the top of your gravel surface. So they're not going to disrupt that gravel. They're only going to lift up your media, your silica sand, your anthracite or green sand, whatever you have in your filter. Following the gravel placement, in this case it was silica sand, probably 12 or 15 inches of silica sand. I don't have a photo, but on top of this there'd likely be anthracite in 15 to 18 inches as well. So that's kind of the general process for filter rehab. Now I just want to go over some of the lessons we've learned through some of our projects and provide some tips for you in your own situations. Filter downtime, if you're looking at media replacement only, you're probably looking at about 2 weeks. Again, they got to come in, vac out the media, put in new media. They're going to have to backwash the media as they place it in lifts. If you have green sand, you're going to need time to charge it. So you're looking at about 2 weeks to do all that. Maybe you can get by with less depending on your system. If we're going to do a full structural and coating rehab, you're probably looking at 6 to 10 weeks. Again, there's all those processes we went through. You're going to have a subcontractor for painting that needs to get in there. By the time all that coordination happens, it's going to be hard to get done under 6 weeks, and it's probably going to be closer to 10 weeks. So of course, what do we do during that downtime? What complaints do we get? How do we handle water treatment during that downtime? And obviously one of the main complaints is probably going to be iron and manganese staining in the system. If you have a filter, you're likely removing iron and manganese. And then another one we've ran into is cloudy water. So first, iron and manganese staining. So what are your options? Well, you could use a temporary filter. This is probably a rare occurrence, but you could actually set up a temporary system to treat water. Likely this, depending on the size of your system, this may be too expensive and deemed really not worth it, but it is an option that's available. If you're not going to use a temporary system, you'd want to utilize a sequestering agent, a polyphosphate. Depending on your systems, you may already feed a phosphate, but depending on the blend, it might be more of an orthophosphate if you're using it for corrosion inhibiting. So you want to talk to your chemical supplier and ask them if you have the right blend for a sequestering agent if you're looking at bypassing the filter. And you should inject that as far upstream as your chlorine injection as possible, but after the clear well. If you have a clear well and you inject your phosphate before the clear well, you've now introduced phosphorus into your clear well and might prohibit bacteriological growth in your clear well. So you really want to inject it after the clear well, but as far ahead as the chlorine as possible. If you inject it after the chlorine, that chlorine is already going to react with your iron and manganese and start to precipitate them in your system. And therefore your sequestering agent isn't going to do anything. If you get it far enough ahead, you'll begin to sequester the iron and manganese and not cause any problems. And then if nothing else fails, there's always periodic hydrant flushing in problem areas. So you still may get some complaints. You might have to address those on a case-by-case basis and flush in the worst areas. Another issue we've run into is cloudy water during filter bypassing. Cloudy water results from dissolved gases releasing in the water. Typically these gases are released during the aeration process, but when we take your filter down for rehab, we're also going to be bypassing the aeration process. Where I've seen this a problem is in systems with clear wells. In that particular situation, we are taking raw well water, pumping it into a clear well, and then using high service pumps to go to the tower. So that water pumped from the wells is now sitting in the clear well, and those gases start to off-gas and create this cloudy appearance in the water. So how do we solve that problem? We came up with two solutions. One was long high service pump run times. What we found out when these complaints were happening was that it was during winter, and the operators had the system set up to pump short run times every few hours. So people that were drawing water near the water treatment facility on that main were constantly being replenished with this cloudy water from the clear well. So they were never drawing water from the tower, they were only getting this cloudy water out of the clear well. The other thing we did to address this was play with the tower settings to get this high service pumps to run during the night. It took a couple days to get it online, and if you have consistent usage, it's pretty easy to set up. But we played with the tower settings. The plant would turn on 11, 12 o'clock at night, and they needed about a 6-hour runtime. It would be done by 6 o'clock in the morning. That way that cloudy water was being pumped directly to the tower. It had time to off gas, and by the time people were using the water the next day, the cloudiness had disappeared. Once we implemented those two solutions, our complaints literally stopped within 2 days. And one other thing I didn't have on here that we also used was actually shut some valves in the system to try to direct the water to the water tower. We noticed, we kind of mapped out where the complaints were coming from, and they were grouped in certain areas. So we looked at the distribution system, shut a couple valves, directed that water towards the tower instead of out to these trouble areas. Another lesson learned, and John referenced this a little bit earlier, is well capacity. And this was the city of St. Bonifacius water treatment plant. We just did a rehab there this last year. This is their aeration header, and you can see there's some buildup on the pipe and the top of the aeration header, or the disc. Water appears to be flowing out of there pretty well, but that doesn't mean there's not buildup inside that disc that's creating extra head loss. So what we actually found before rehabilitation of the system, their well was pumping about 350 gallons a minute at full speed. After we were done rehabbing, they could now get 500 gallons a minute out of that well. That's a substantial increase in capacity. And what that could lead to, depending on your system, it may actually eliminate the need for an additional well. If your system is teetering on the point of you don't have enough capacity in your well, you may be able to gain capacity just by rehabbing your filter or keeping your disc clean and gain that capacity. And John already referenced cleaning those discs and making it a typical maintenance item. Another issue we came across was chemical mixing. Steel filters don't always offer adequate mixing of chemicals before the filters. You may be adding chlorine or permanganate, depending on your system. You really want to inject that at a point of turbulence and far enough upstream to get mixing before your filters. Allow for those reactions. So I want to start off looking at a cylindrical gravity filter. In this example here, there's a chemical feed point right here at the bottom of the detention tank, and you can see that's just upstream of the flow splitter to the filters. So there's very little mixing and reaction time before it splits to each of the filters. What I've found is if you have individual sample taps on each of your filters in this situation, we've noticed that two of the filters, or one of the filters, is receiving more permanganate than the other filters. So you might have pink water issues out of one of your filters. Conversely, if you're using green sand, now you're going to back that off because you don't want pink water. Well, now you're actually underdosing two of the filters so you don't get pink water on the other filters. Now you might lose your charge on your green sand. So there's a lot of issues that come up if you're not getting adequate chemical mixing. So we recommend using an application point before the detention tank, adequate time to mix and react before it splits to the filters. Looking at a rectangular gravity filter, I'll go back to St. Bonifacius. We ran into this issue after the rehab and starting the filter up. We noticed that filter 1 was receiving more permanganate than the other filters, and actually as you went down the line, each filter was progressively had less permanganate in. We simply took a white styrofoam cup, looked at the influent to each filter, and just you could tell in the cup how pink they were, how much permanganate was in each cell. So what we did, we moved the diffuser back into the detention tank, and we submerged the diffuser. Here I actually have a short video of this installation. Well, it doesn't look like it's going to play. Anyway, you can kind of tell just from the snapshot of it, but what we have here is, this is back in the detention tank. It's a steel gravity filter. What you see here is the actual effluent weir from the detention tank. That drops into about an 18-inch wide launder that runs around the corner and then disperses into each filter with a V-notch weir. Before we move this, the injection location was actually in that launder, probably 8 feet upstream of that first V-notch weir dumping into the first filter. So there was not adequate mixing before that first filter. what I did is actually took this, created this new diffuser and put it upstream of that weir. And it's actually submerged, it's hard to tell here, but it's about 3 or 4 inches under the water. So a couple things that does, it helps it disperse the permanganate, but it also continuously cleans that diffuser. If you have diffusers that are out of the water and it sits there, you're going to crystallize and you're going to plug. This application, it kept it clean, it also dispersed the permanganate. And then as it flows over this weir, there's a lot of turbulence on the backside of that weir. And this was real simple to do. One trip to the hardware store and I did it myself. So if an engineer can go out there and make this work, you guys can do it no problem. As soon as we did this, we let it run for about an hour, kind of switch over. We went to each cell, sampled them, and the permanganate was split evenly between the cells. I just want to talk a little bit about backwashing, not a particular case study here, just some general troubleshooting topics. Improper backwashing, what problems can occur? You can have loss of media, poor filter performance, and reduced filter run times. One thing we'd like to stress is if you run a manual backwash system, you should backwash your cells a different order each time you backwash. So let's just say you're backwashing once a week. First week of the month, you start on cell 1, do cell 1, then 2, 3, 4. Second week of the month, start on 2, you can do 2, 3, 4, 1, and switch that along. If you always do the same cell first, it's going to create issues with your backwash. So always rotate those. A lot of operators we talk to have a stopwatch or something they use. They hang on the filter that they need to backwash first the next week, and that's how they do it. So. Another thing we learned was using control for the backwash systems from the supervisory control panel. Some of the old filter systems might have a dedicated control panel at the filter. These systems work, but they're not very operator friendly. There's not a good interface. So what we did is we brought those controls back to the control panel and gave the operator a much better interface to work with, more options, and just overall more control over the backwash sequence. One of the things we did with that was created a variable wash time for each filter cell. There's actually operator set point, so each filter cell can be backwashed a designated amount of time. The reason we did this is we were backwashing with high service pumps, and the first cell was getting cheated on the backwash cycle because the high service pumps had a ramp up time on the VFD. So that first cell would take about 60 seconds to reach full backwash flow rate. And you can imagine, well, that's not really a big deal, but it's a cumulative effect because every time it backwashes, that filter is washed 1 minute less than the other filters at peak flow rate. This way you can go in, set that first filter for say 6 minutes while the rest of them will backwash 5 minutes. Just another operator set point, more control over the system. Another issue we've seen, improper water level control. And this is during the air wash process. Here's a slide showing a backwashing process and air wash. As noted there, the water level is about 6 inches below that weir level. If you get closer than that, you're going to start to get bubbling up over that backwash weir, and you're likely going to lose media into that weir. As John said, depending on your filter, you may or may not be able to actually visualize this, depending on the access you have. If you do have access, I would recommend watching it periodically. Once the set points are in, there shouldn't be any reasons that would change unless you accidentally change something. But it'd be a good thing to check every once in a while, especially if you notice any problems. If you notice media in your reclaim tank or more coming out of your backwash than normal, this would be something to check. Again, just a reminder, a proper backwash rate is between 12 and 15 gallons per minute per square foot. Just a number for you guys to keep in your head for what your flow rate should be for your filters. So again, just to go over what we've kind of talked about, needs for filter rehabilitation, the media fouling and scaling, any structural deficiencies or leaks, and then poor filter performance. And again, I'll go back to sample, sample, sample. The best way to know if there's any problems is to sample and to see those changes. If you know how your filter reacts and you see changes in your water quality, you know something's going on. And I know a lot of times it's tedious, but in the long run, it's going to help you catch those problems sooner. And then if you need to call an engineer, it's a lot easier for us to take some data and help you. If that data is not available, we likely need to come out and collect our own data or you need to start collecting data. So I know for periods of time it might seem like it's not worth it, but when you start to have problems is when it's going to be worth it. So again, highly recommend sampling and good record keeping. And then finally, once you determine there's a problem, what's the scope of your work? This is obviously going to take input from the operations staff, what problems you're seeing. Are we going to do a media-only replacement? And again, we might be looking at a pilot study to determine if media should be changed or replaced. Are we doing media and coatings? Are we doing a complete underdrain? So just some things to keep in mind when we're looking at a rehab project. And then as John said, you need Department of Health approval for any type of work under these conditions. So with that, we'll open the floor for any questions.
Sure, yes. So when you cut the bottom, basically the top off the plenum and then pour it with concrete instead of rewelding the top onto the plenum?
Correct.
Okay.
Correct.
Second question,
The issue is if you weld the plenum back on top, is the weld's going to damage the paint underneath. You have exposed metal.
second one, we exceed arsenic out of our wells. And so if you're down 6 to 10 weeks pumping raw water out into your system, is that gonna be Department of Health all right with
Well,
that?
we have some people in the Department of Health here. It's dependent on I guess, we'll let them answer maybe if they want to.
So then to set up a temporary filter.
Oh, there's Carla actually. Let Carla answer.
Yes, you're allowed to use it, but you need to talk to your district engineer. Arsenic's a chronic contaminant and works in your body over many years. The one exception is nitrates. You're never allowed to bypass. If you do, you have to notify the public within 24 hours if you're drinking elevated nitrates or nitritis. That's the one exception.
Very good. Any other questions?
There's one in the back.
How big of a project is it to add air to pressure filters? We have Tonka pressure filters that didn't come with air.
How big of a job is it to add air to a filter? That's what he's asking.
You would have to take the filter down, much like we did in Clear City, remove all the media, the under drain gravel. You would cut in your air wash header, which by doing that, you're gonna be damaging the coatings. You would have to at least do a partial coating repair on that. And then obviously adding the blower into the building may or may not be a challenge, may be easy, maybe a little more of a challenge, but so you would have to, problem is once you take the media out, typically it's very hard to salvage that, if you pull it out of the back truck. So I think I've only seen one time where people tried to salvage the media. All other times it's just easier to pull the media out and get new. So once you put it in a back truck, you're never quite sure if it's sanitary, so we really don't recommend reusing that unless you're gonna physically shovel it out by hand, so.
Is the replacement of the media the expensive part, or is the air system the expensive part?
I think it's going to be equal balance in all of them. If you have green sand, the green sand currently is very expensive, and that may be the expensive part. If it's silica sand, that's quite a bit less money. So that will, so it's dependent on your media.
So we're gonna replace our media in like 5 years, so that would be the time to do it.
Absolutely recommend adding it at that time.
Is there any applications where you wouldn't want to use air?
No,
Okay.
not to my knowledge. Air is, we do that as standard in all filters.
Do you guys convert to sodium permanganate, or is that still potassium?
It could be either. It's
At that particular site, I think that's
That was-
St. Bonifacius, or
that was potassium.
okay.
Yep.
Any others?
So we got one for,
Is it worthwhile switching to simul wash? You just have air wash and water wash now, is it worthwhile? Put the drops in and.
the question is it worthwhile to switch over to Simul Wash, which is trademark name. It's the media retaining baffle, backwash baffles. We're doing that maybe 50% of the time on new filters right now. Gravity filter, it's run right, really you shouldn't get media loss. What you do see is if you have any of the issues, such as Brian was pointing out, where the drain downs don't work right, if your level sensor's off, it's protection, it's belt and suspenders. You won't lose any significant media, even if you have those failures. It will get your media a little bit cleaner, a little bit faster, so you save a little bit of water. So that can be an advantage. So it's a balancing act. Groundwater media is usually cleaned very quickly, so it's not the driving force. Lime softening plants, it's much more of a driving force. The lime sludge is a little harder to clean, so the cyma wash is much more valuable for a lime plant. So the answer to your questions, we're doing about half the time. So there is some value, but it's kind of on the edge of if it's cost effective.
What are some of the advantages or disadvantages of silica sand versus green sand in a filter, like a pressure filter system? Typically.
Yep. The advantage of silica sand versus green sand, and I'll throw out again, there's also an Ironman media that's been used some. I don't have quite the experience there, but silica sand is just simply the sand that you would see, say, in a sandbox. It's graded, it's cleaned, works very well in iron. It does not work as well in some manganese removals. The green sands are coated media that have a chemical reaction with the media, with the manganese that removes that. The disadvantage of green sand, one is cost. Two is you have to always feed permanganate to recharge it. If you don't feed enough permanganate, you lose the charge and you have nothing now more than expensive silica sand. And actually during the process of losing the charge, you can actually increase your manganese results and have poor performance on that. So it's one I would really recommend you pilot study before you take a jump on that, because right now green sand is a lot more money. There are certain times, City of Fulda, we did a pilot study, it was absolutely night and day difference between silica sand and green sand. Silica with their water just would not perform, but green sand performed very well. So.
John, I was going to add to that. We've had the experience with systems with higher TOC and ammonia, where you have a very high permanganate demand on your raw well water, and that becomes very hard to keep your charge on your green sand. So if you have one of those situations, you might actually want to look at silica sand, because you'd have to feed so much permanganate to overcome that other demand that it's going to be hard to maintain that charge.
What specific things can you test for to determine if you have bacteria or biological fouling in the medium?
What can you test for to determine if you have biological fouling? The first test would be if you have biological activity. And there's a couple different tests with that, which we've probably discussed quite a bit. Heterotrophic plate count is kind of a generic catch-all test. HPC is the initials for that. I think it's a $12 test. It's pretty low cost. There are a couple other tests out there, but that's probably the one we use the most often. If you get positive results on that, that means you have bacteria, but that doesn't mean you have a bacteria problem. From there, it just becomes a matter of monitoring performance. Are you getting short runs? Are you getting excessive head loss? Whether or not you're having issues with bacteria. There's numerous filters have bacteria, you probably don't know it. They run great. There's some designed for it intentionally and they're doing very well. And there's a few that really are struggling with it. Just they're getting a strain of bacteria that's just not compatible with what they're trying to do. So the heterotrophic plate count test is the catch-all. It's a little bit broader than just the coliform test. That's it. Thank you very much.
Yes, give them a round of applause here. We'll stay on schedule.